Hi everyone, I am Priyavashni, Assistant Professor, Department of Computer Science from Dr. SNS Rajalakshmi College of Arts and Science. Today our topic is unions in C programming. Simplify the memory sharing in C. In empathize, why we need union means problem is when multiple data types needed to share the same memory space. Example, storing either an integer, float or character in a single memory location. So need is memory efficiency is embedded of low memory systems. Image idea, visual of memory blocks being shared among the data types. First, the union is in C. A union is a memory sharing data structure. Structure is equal to many boxes. Each member get its own box. Okay, in union is equal to one single box, but different members pretend they live inside it. Think of union like one room. It's many people can enter. Okay, but only one person can stay inside at a time. If a new person enters, old person has to leave. Same way, when you assign a new value to a new member, previous member's value is overwritten in the same memory. Why is union created? Why is union created means C was designed in 1970s for device drivers, operating systems, embedded systems, hardware level coding. Those system requires memory to be saved, different interpretations of same memory, fast low level control. Union solves two major problems. First is a memory wastage. Example, suppose we need to hold only one of the following at time means int is 4 bytes, float is 4 bytes, character is 1 byte, right? So structure is equal to 4 plus 1 is equal to what? It is in 9 bytes. In union, maximum 4 comma 4 comma 1 is equal to 4 bytes only. For savings 5 bytes per unit. Per unit it saves 5 bytes. If 1000 search entries, it saves 5000 bytes. B. Second is in different views of same data. Union allows you to look at the same bits differently. Example, the union, we create the union and the number is in variable name, float, F, unsigned int I. Same 32-bit can be interpreted as IEEE float, binary integer. This is called the type tuning. Third is in union syntax. In union syntax, not just theory, deep breakdown, union data or union name, data type member 1, data type member 2. In data type member 1, we give a int I. In data type, we give a float F. In data type 3, character CH. Okay, what actually happens internally, compiler find the largest member. Int is a 4 byte, float is a 4 byte, character is a 1 byte. Largest is equal to 4 byte. So compiler allocates one 4 byte block. Okay, the memory view is 4 byte block. We give the I, F, CH. I is an integer, F is a float, CH is a character. All share this space. So every member's behind such a byte is 0. Then crucial characteristics, rule 1 is only loss written member is valid. If you write to one field, all other get overwritten. Rule 2 is union size is equal to size of largest member. This includes padding if needed. Rule 3, all members start from the same memory address, unlike structure whose members get different addresses. Rule 4, you can't store multiple values at once. Okay, so union is not equal to structure. Union either this or that. In rule 5, you can use pointers to unions. Very useful in embedded C. So example, explain in maximum depth I can. So okay, union data d dot I is equal to 10 means it print d dot I. Okay, the memory d dot I is equal to 10 means the binary of 10 is what it gives that value. Okay, in next, see d dot F is equal to 3.5 means memory replaced with IEEE float 3.5. 3.5 in float is equal to 0 into 4060 zeros. Then binary, what is the binary value? It prints. And finally, d dot ch is equal to a means is an ASCII character. So ASCII a is in 65. So 0 into 41 is equal to what the value that is. That this overrides only the first byte, but since all members share the memory. Now the union hold garbage for a, I and an F. Okay, memory allocation in union. All members share the same memory. Size of union is equal to size of the largest member. Efficient but override previous values. Image field memory diagram comparing structures versus unions. So in compiler wants to guarantee every member files without overflow, without shifting base address. So it allocates memory is equal to maximum size. What about alignment? What about alignment is some system requires int aligned at 4 bytes, double align at 8 bytes. If your union has a double, union size may become 8 bytes, not a 4, right? So example, then union, we create a union keyword and x as a variable name, then character C 1 byte, double D is an 8 byte, it's not in 4 byte, okay? Union size what? It is an 8 byte. In union versus structure means, we comes from union to structure. Each member has separate memory. In union, all members share the memory. In structure, all members can be accessed. In union, only one at a time. In structure, sum of all members. In union, size of largest member. In structure, general purpose data, it is a memory optimization. So in structure, we use the struct keyword and the variable name is x. Int a is on 4 bytes, character b is 1 byte and float c is 4 bytes. Total 12 bytes, actually maybe 16 because of padding. Okay, because of padding it actually may be 16. In union, why? We use an union y, int a 4 byte, character b is 1 byte, float c is and 4 byte, means total 4 bytes there. It is the largest member, right? It is the largest member in int, character and float. Struct store all values, union store only one value. Type pruning, the most powerful union feature. This is where union become magical. Example, we use the union keyword, test as an variable name, unsigned int x, float y. Okay, if you do t dot x is equal to 0 into 3 f8000 means it prints what is the output is 1.0. Okay, in unions lets you convert float int without casting. Access the raw bits, perform low level debugging, write a fast APIs for engine, kernels, device drivers. When is a union is dangerous? When is a union dangerous means if you forget that only last member return is valid, you will get garbage. If you try to store large values in smaller types, example union u character c int I means writing to I may overflow into C unexpectedly. Okay, so using union for type tuning breaks strict aliasing in some cases, but compilers like GCC allow it as an extension. Network protocol passing, same data interpreted as a header, flag and raw bytes. Graphics and name engines we use. So union use the fast float int conversions. And operating systems, kernel programming, type safe memory reinterpretations. In microcontrol drivers, simply register, read and write. Okay. So in prototype, we can write in union example changes value in test, observe the memory sharing. In outcome, understand union is equal to memory efficient structure. One value at a time only, best for low level coding. Okay, thank you.